The last step is we'd like to interpret the meaning of this 95% confidence interval. And that goes a little something like this. It's a blend of the confidence interval statement and the slope statement. I am 95% confident that the true average percent increase in the response variable, which is acceptance rate, when the explanatory variable, which is rank, increases by 1. Is between, and then state the interval. And we should note that this is pretty substantial because it means that, for each rank down in school, you got, close to a 1% chance better of getting into the school when you apply. And of course, this can't go on forever because this would imply that by the time you get to the 100 or 150th best school in the country, your chances of getting in when you apply are 100%, which clearly isn't true. Another thing that we need to be careful about is that we are running an analysis on a slope that is actually reasonable. So of course, if the model that we used, the linear model, doesn't work, then the slope doesn't mean anything. And so there are conditions to check. And let's look at those conditions. The first condition is that each observation must be independent. And in the case of the analysis that we've just done, that's not true. The reason that's not true is that the rank of the number 2 school is affected by the rank of the number 1 school, and so on. These ranks are dependent on each other. So each rank affects the other ranks. Okay. Proceed with caution. The next condition, number 2, is that the linear model must be appropriate. And we answer that question by looking at the residual plot. In this case, the residual plot has no pattern, which allows us to imply that the linear model is appropriate. Next, number 3. The standard deviation of the y values must be constant as x increases. And the best way to explain this is to show you an example where it doesn't work. I took the residuals for a different set of data and compared them to the x values. So the residuals measure the standard deviation of y. And we're looking at what happens as x changes. Now what you want to notice is that as x increases, the the residuals are also increasing. And so what that suggests to us is that we're losing predictive power as we move this way. Or in other words, the standard deviation is not constant. But of course, that's only referring to this residual plot right here. If you look at the residual plot for the rank versus acceptance rates data, you can see that there's no real change in the spread, the vertical spread of the residuals as we move from the left to the right. So we're good here. Let's phrase it this way. Residual size is constant as x increases. That brings us to the last condition and the last thing we need to talk about here. This is the most unusual of the conditions. It's this. The response, which is the y values, must vary normally about the regression line. And so what we want to do is we want to look at the residuals. So the first thing you need to realize is that the residual is the variability of y about the least squares regression line. So what we want to check is whether the residuals are linear. And here's how you do that. I just happen to have the calculator in my hand here. And okay, so I've got rank here in L1, and I've got acceptance rate here in L2, and I go to stat plot. I've already run the regression. I do that by doing stat calc one variable. Oh, sorry, no. Try that again. Stat calc linear regression. Okay. Once you do that, your calculator has saved the residual plot. So you can go to stat plot and select one of them. Turn the normal probability plot on, and then under data lists you want to put in residuals. You can find it under list, and that'll get that for you. And then you go zoom 9 and look at that residual plot. And what we should note is that it is essentially linear. So, draw a sketch where we note that this is the predicted z-score here on the x-axis, and the residuals are going to be on the y-axis, and our graph, it's not perfectly linear, but there's no clear curvature to it. So, our conclusion will be as follows. The residuals vary normally because the normal probability plot is linear. So let's quickly review. There are two skills that we've learned today. That first skill is how to construct a confidence interval for the slope of a least squares regression line. And that second skill, which we've looked at here on the second page, is how to check the 4 conditions in order to make sure that inference on a least squares regression line slope makes sense. And that concludes today's lesson.